All right, good morning, guys. We'll just wait another quick minute to make sure everyone's logged on, and then we'll get started. Take this time to make sure you're muted, please. I see a whole bunch of people at the bottom that aren't, so take this time to do so. All right, good morning, everybody. Nice to see you again. Friday, last day of class before the weekend. So just a couple of quick notes before we start. First of all, make sure you're all muted. I see a couple of people still not muted, so please take the time to mute yourselves. Second of all, there's the group chat that you can open. I just posted at the top of Google Classroom. Make sure you have that open so you can ask questions. Like I said, feel free to just pop in if you have a question too. I'm broadcasting a little differently, like nothing will change for you, but we're trying to solve the mic problem. So if at any point I'm cutting in and out, let me know, because then we'll try something different. Or if you find it's better, let me know too. Just let me know in general. That way, if it's not fixed, that we can fix it. Another note, yesterday you may have seen that we posted, or I posted, the situational problem date. So it's not this coming Wednesday, it's the following Wednesday, which means your attendance that day is absolutely mandatory. No excuses, no I woke up and forgot, I woke up at 12 and couldn't get here. You have 2 weeks, a week and a half notice now. You need to be able to get to the school on that day, absolutely. It's a final exam, it's mandatory. 0 is 0 if you don't show up, okay? So we're going to talk a little bit next week about what's fair game for that, because we have the whole bunch of CST topics that are 100% fair game for that exam, and anything that we cover together up until then is also fair game. So we'll go over a list of topics and strategies for that. In the post it says you're allowed a memory aid. That's legitimate, so you are allowed a memory aid for that. We'll also go over not practice memory aid, but I guess a guide for your memory aid that could help you out with that. All right, so yesterday I provided you with assignment 2 feedback. There are still a lot of people that aren't quite completing it, so make sure that you're doing so. I noticed that more people are completing the forms than are completing the docs. Make sure you're doing both, because we're dealing with part A, B, part C type questions. Yes, you'll get a checklist of topics for their memory aid. That was a question that was just asked in a chat. So will you get a list? Yes, you will. Yes, so assignment feedback, please make sure you're doing them. There were an awful lot of people who didn't. This is an opportunity. You have the solutions, you will have the solutions. So it's not about understanding the solutions, it's seeing if you can do it on your own and what you got wrong if you didn't, okay? So there's no use in just copying down the answers. So you really, the point of this is really to try the problems on your own and to get feedback of where you're making your mistakes. So it's super, super, super important to be doing those. And I notice a lot of people aren't doing them. So do them as much as possible. You're getting another one today, okay? Okay, so what we're going to do now is we're going to be going over any questions. I've already been asked this newest assignment that you got yesterday to do question number 2. In the side chat, we just got assignment question number 3. So take this opportunity now to post in the side chat any questions that you have that you want to go over now. We'll take 10-15 minutes to go over those problems to make sure we're all understanding what's going on. So I'm going to wait a minute. I'm going to see what kind of questions pop up, and then we'll go from there. Okay, so take this next minute to be doing that. Okay, so we're going to start off with, I'm trying to organize the questions just to do this as efficiently as possible. So we're going to go over assignment 3, question 3. So if you want to take a minute to open that up, assignment 3, question 3. So basically in this question, you have a rectangle. They say that the area is 18x squared plus 9x minus 20, and that this side measure is x plus 4. So there are 2 different ways you can do this problem. So area is length times width. So we know that the area is x squared, 18x squared plus 9x minus 20 equals 3x plus 4, and we don't know what the width is. But we could just divide both sides by 3x plus 4. And once I have this division, I can do long division here. There is another way, okay? When you have area of a rectangle, let's say they give you the area is 24. It could be 1 in 24 the dimensions, or 2 in 12, or 3 in 8, or 4 in 6. So we don't know which pairing is making up this 24. So we need more information to find it out. With a rectangle, you don't. With polynomials, you don't. Because when you have a polynomial, there are only one set of factors that will multiply to get that. So all I have to do is factor this using the tools that I have. 18x squared 9x minus 20 gives me a product of 360. From here, you're going to fill this out. So I have 1 and 360, 2 and 180. It's going to go on for a very long time. Eventually, you're going to get 15 and 24. With a negative 15 and a positive 24. So I'm just skipping a couple of steps to just save us some time. So we have 18x squared minus 15x plus 24x minus 20. I can regroup here. I can pull out a 3x, and I'm left with 6x minus 5. And here I can pull out a 4, and I'm left with 6x minus 5. Reworking these, I get 6x minus 5 and 3x plus 4. So notice how we got the 3x plus 4. So now we have 6x minus 5. So with area of a rectangle, when you're involving polynomials, you don't have to know one of the factors. You just factor because there's really only one option. Then they're asking you for the perimeter. So it's the perimeter length plus 2 width. So you would just plug in what you have. Solve. So this distributes there. Give me 12x minus 10. This distributes to both. So give me 6x plus 8. Final answer, 18x minus. So this is going to bring us to the next problem. So that was class 3 assignment. Class 4 assignment, you have a very similar problem. So it says number 2, so this is assignment for number 2. So it says you have a rectangle. You're expecting it to make a new rectangle. Now it's saying here that this area is 2x minus 11x 12. And that here you're going to add 4 to each of the sides. We're going to do the same thing now because with a binomial, or trinomial, sorry, like I said, there's only one way to factor it. So my product is 24, and my sum is negative 11. And 24, and 12, 3 and 8, 4 and 6. Everything's negative since it's a positive product. So I'm going to go with negative 3 and negative 8. So 2x squared minus 3x minus 8x plus 12. Regroups here. I can pull out an x. I'm left with 2x minus 3. And here I can pull out a minus 4. And I'm left with 2x minus 3. These rework. So the 2x minus 3 and the x minus 4. meaning that these dimensions here are 2x minus 3 and x minus 4. I want this whole length, and this whole length so that I can find the area of the new rectangle. So I'm extending each of them by 4. So if I have x minus 4, I'm adding 4 to it. Gives me x. X minus 3, I'm also adding 4 to it. That gives me 2x plus 1. I want so don't do this. It'll just be one quick second. Okay. So we had our new lengths, so we're just going to find the area. Plug them into our area formula. We distribute in, so the new area was 2x squared plus x squared. So that answers the question, the assignment number 2. And how do you find the perimeter of a rectangle with just area? I was asked to go over the Google form from yesterday. So we'll take a quick look at these. In class 1, you had 6x to the 4, x cubed plus minus 36x minus 84x here. So it says this is the product of 3 irreducible factors. So we need to find the factors. So first, I'm going to see what I can take out. I can take out a 2, and I could take out an x. And 42. Here, I can factor this by grouping. So within my big bracket. Here I could take out an x squared, and I'm left with 3x plus 7. Here I could take out a minus 6, and I'm left with 3x plus 7. This, I get 3x plus 7, and here I'm left with x squared minus 6. Factored. Now what they want is the sum of the factors. So it's 2 plus 3, so 2x plus 3x plus 7 plus x squared minus 6, and this will put it together. So I have an x squared that's almost 7. And negative 6, which means it's plus 1. That is option C. The audio is still bad. I'm just trying something here. How's the volume level now? Is it better? It's better now? Okay, we'll try it like this and let me know if it still cuts in and out. Okay, so now we'll go over Google form question. Well, there were 2 question 3s on this one, that's okay. So we'll go over the second question. So here the second question is, we are basically simplifying this. So I have the top and the bottom to deal with. So 4x squared minus 25 and 2x squared plus x minus 15. So in the first one, I don't have a GCF that I can factor out, but this is a difference of squares. So I square root this one, I square root this one, 1 plus, 1 minus. Here, there's no GCF that I can take out, so my product is negative 30. Remembering it's this times this, my sum is 1. So I have 1 and 30, 2 and 15, 3 and 10, 5 and 6. So my sum is positive, so these are negative, and this is what I'm choosing. So I have 2x squared plus 6x minus 5x minus 15. I regroup here. I pull out a 2x, so I'm left with x plus 3. And here I pull out a negative 5, so I'm left with x plus 3. Regrouping, I have x plus 3 and 2x minus 5. So my new rational expression here is 2x plus 5, 2x minus 5 over x plus 3, 2x minus 5. So all I have to do is cancel out these 2 factors, and I'm left with 2x plus 5 over x plus 3. How's the volume level now? Is it still cutting in and out, and is it high enough? It's better? It's better for everybody? Okay. Okay, let me know. Awesome. I'll figure out a way to get it. So it's more consistent, but it's quieter. Huh. Okay. All right, let me see how I can fix that. And we'll go from here. So the last question, what are the restrictions of the following expression? So when I'm dealing with restrictions, I'm dealing with denominator only. So I don't care about the numerator right now. So I'm just going to deal with the denominator. So this I can factor out an x. After that, I can, this is a difference of squares. So I square root the first, square root the second, and a plus and a minus. Restrictions are just whatever value would set the denominator equal to 0. So all we have to do is factor it and then set each of the factors equal to 0. So you're just solving for potential issues with values of variables. Okay? So here from 1, I set each of them equal to 0. So x is 0. 2, I set this one equal to 0. So I move this over. So x is 2. From 3, I set x plus 2 equal to 0. So I move this over and get negative 2. So my restrictions are the 3 values of x that would set my denominator equal to 0. In this case, I get 0, 2, and negative 2. So here what I'll do is I'll just to make it hopefully a little bit more clear, is I'll show you what I mean by this. Exactly. So here, if I plug in any of these values, we'll try 2. So let's see what happens when I plug in 2. So 3 times 2 squared gives me 3 times 4. That's cubed. Hello. 3 times 8 minus 2 times 4, and this is 16. 2, 3 is 8. 4 times 2 is 8. So I get 24 minus 8 minus 16 divided by 8 minus 8. So this gives me 0 divided by 0. This is a problem. Type this into your calculator. It gives you an error, and that's from this guy. So this is not a problem. This is a problem. So we can't have a denominator equal to 0. So we're saying, well, I actually can deal with this polynomial. It's fine as long as x is not 0, as long as x is not 2, and as long as x is not negative 2. If x is 5, we're good to go. If x is negative 1,000, we're good to go. If x is 2 million, we're good to go. If x is 0, it's a problem. If x is 2, it's a problem. If x is negative 2, it's a problem. Okay? All righty. What? Okay. 0 is not always 1. The only reason 0 is a restriction is because we have this as a factor. For instance, let's just do a simple one. If I have, no, you should not involuntarily put 0. If I have this, if I put this and you have to state the restrictions, this is factored, so I'm just going to set this equal to 0. This moves over, and I divide by 2 to give me x is -5. That's the only restriction. Because if I plug in x is 0, I get 5, 0, minus 3, 2 times 0 plus 10. 5 times 0 is 0 minus 3. And 0 plus 10. That gives me -3/10. That's a number, that's not a problem. So plugging in 0 in that case didn't give me an issue. So only include 0 as one of your restrictions if you have a factor that allows you to put 0 as a restriction. Okay? All right. So, rational expressions, same thing as fractions. And we talked about how what we do with rational expressions, or what we did with fractions, we're going to do with rational expressions. The only two things extra that we have to do are restrictions. Actually, only one thing extra. The only extra thing we do is restrictions. For fractions, we simplified, multiplied, divided, and then added and subtracted. So today we're going to do the rest of those. We're going to multiply, then we're going to divide, then we're going to add and subtract. And you're going to see that the steps are very similar. The only thing that's different is the factoring part of it and the stating the restrictions. So we're going to start off with multiplying. It doesn't need to be this small. So I'll give you a minute to write this down and then we'll continue. Okay, so when we are multiplying rational expressions, like I said, step 1 with rational expressions is always factor. Always, always, always. So we're going to factor everything. You're going to state the restrictions most of the time, and I'll tell you in which situation specifically that we don't. Once you do that, you cancel out any factors that exist in both the numerator and denominator. In any fraction. Then you're going to perform the multiplication. So let's see what this looks like. Okay. Question number 1, multiply the following expression. So we have 4 different polynomials that we're going to factor. 1, 15x cubed plus 5x squared. This is GCF factoring, so I can pull out a 5x squared. And I'm left with 3x plus 1. 2. 15x is reduced, or is a factor. 3. 3x squared minus 5x minus 2. Not a perfect square, not a difference of squares. We have to product sum. So I have a product of -6 and a sum of -5. So I have 1 and 6, 2 and 3. This is negative, so here we go there, and I've got 1 and 6 actually. So 3x squared minus 6x plus x minus 2. I regroup 3x, x minus 2, plus 1, x minus 2, and then I regroup. I do the same thing for factor number 4. So I have 9x squared plus 6x plus 1. Now, this is a perfect square. So this is 3x and 1. Plus means plus. And we test it out. 3x times 1 is 3x, times 2 is 6. So we're good to go. If you didn't recognize this, that's okay. You can always product sum. It just takes longer. So we'll do it just to show that it gives us the same thing. So I get 1 and 9, 3 and 3. Obviously 3 and 3 are my root to choose. So I have 9x squared plus 3x plus 3x plus 1. Regrouping here, I factor out a 3x plus 1, and a 1, 3x plus 1. So if you rework it, you see here that I have 3x plus 1 times 3x plus 1. That's the same as saying 3x plus 1 squared. So if you don't recognize the perfect squares, it's fine. You'll get to them by product sum. You're just adding extra steps to yourself, which you don't really want to do. If I'm doing restrictions, restrictions come from the denominators. So I have one factor here, and I have 2 and 3. But 2 and 3 are identical, so in theory, we don't have to do them both. So from 1, you square root the first and the third for a perfect square, and then you test the middle by taking the first and the second and multiplying them and then doubling it. So 15x is 0. So in this case, we do have a restriction of 0. From 2, 3x minus 1 plus 1 equals 0. So I move the 1 over to give me -1, and I divide by 3. So x is -1 over 3. This is identical though. So I don't really need to do it again because the same restriction is going to happen. So the restrictions for this problem are x cannot be 0 and x cannot be -1 over 3. So this is all my side work. Now we get back to the nitty-gritty, the actual rational expression multiplication. Okay, so I have two separate questions. Why are you looking for restrictions right now? Because unless stated otherwise, you always have to solve for restrictions. Oftentimes, if you get it in a part A or a part B question, it will say as phrase, and I'll show you the phrase after. And with that phrase, you don't have to do restrictions. But if it doesn't have that phrase, you do. Would what change with the squared? The restriction? Well, 3x plus 1 is 3x plus 1 squared. What am I doing with the red box? So basically, the whole goal of all of this was to solve this. So now, what I've done is by factoring, go away, I've turned this into this. Yes, for rational expressions, you always have to do restrictions unless stated otherwise. So now my goal is to just get rid of stuff. So I see a 3x plus 1 and a 3x plus 1. So it's a lot better. Awesome. Okay, so I get rid of those. 3x plus 1, 3x plus 1. Final thing I reduce, well, 5 and 15, if I divide them both by 5, I can reduce that. And then finally, I can reduce the x squared with the x. And then I just look at what I'm left with. So here I have an x on the top and the x minus 2. And on the bottom, I'm left with the 3. So that is the reduced rational expression. I didn't use the perfect square trinomial. I just put it into two different terms because it's easier to see if you're canceling. But it's the same thing, right? Like if I write 2 squared or if I write 2 times 2, it means the same thing. So it's just easier to see if you separate them for canceling purposes. Why wouldn't you find restrictions on some numerators but other use? Okay, so here, you do not find restrictions on numerators. You only find restrictions on denominators because having 0 on the top of the fraction is completely legitimate, whereas having 0 on the bottom of a fraction is not. So you only do restrictions for denominators. There's one case scenario where you would do a numerator, and we're going to look at that in about 10 minutes. But other than that, restrictions are for denominators only. Yes, I can cross out things that aren't under the same division line. So if you look, this purple here got crossed with this purple. So as long as it's a top and a bottom, it doesn't matter. So you're crossing out tops and bottoms. The 15 and the 5, I divided them both by 5 because if you look on the side, 5x squared divided by 15x, well, x squared divided by x just gives me x. And what is 5 divided by 15? Well, that reduces to 1 over 3 because I can divide them both by 5. So I just divided them both by 5 here to make it a little easier to see. Okay. You have to reduce it as much as possible. Okay. So if you have to reduce. So if you had 5 and 15, this is not reduced. So you have to, just like with fractions, reduce as much as possible. to get this. Here it is. You had 5 over 15. Five over 15 is 1 over 3. Yeah, exactly. So I have 1 over 3. But I don't have to write the 1 when it's a coefficient, right? So that's all you're doing. You're just taking the fraction, you're reducing it. No worries. I'd rather you ask than not ask, okay? Always ask. All right, number 2. I have 1, 2, 3, and 4 as factors. So I'm going to factor them all. So here I could take out a 3. Here I have a trinomial. There's no GCF. So here the product is -12 and the sum is -4. So I have 1 and 12, 2 and 6, 3 and 4. Product is negative, sum is negative, meaning the bigger numbers get the negative. So I have this one. So x squared minus 6x plus 2x minus 2. I group these. X gets pulled, leaving me with x minus. What did I just do? Oh, there's a 12 here. Haha, 12. And I pull out a 2x minus 6, and I regroup. So that is the second one factored. The third one factored, this is a binomial, so you only have 2 options. Either it's a difference of squares or you pull out a GCF. There's no GCF to pull. It is a difference of squares. There's a difference, and it's 2 things that are square rootable. So I have x and 6 plus minus. And then number 4, 2x plus 6. All I can do here is pull out a 2. In terms of my restrictions, anything denominator, so any of the factors from 2 and from 4. So I have this one, and this one. So from 1, I have x minus 6 equals 0. So x is positive 6. From 2, I have x plus 2 equals 0. So x is negative 2. And from here, I don't need to deal with this 2 because theoretically we've got 2 times x plus 3, but 2 never changes, so it doesn't impact anything for me. So for 3, I have x plus 3 equals 0, so x is negative 3. So my restrictions are x cannot be 6, negative 2, or negative 3. Once again, we are doing, the whole point of this is to solve this rational expression. So now this rational expression turns into my factors. So I have 3, don't want to do this in red. 3x plus 2. On the bottom here, I have x minus 6, x plus 2. On the top here, I have x minus 6, x plus 6. And here I have 2x plus 3. So now I'm doing a canceling game. Anything I see that's in a denominator and a numerator goes. So I've got an x plus 2 that'll go with this x plus 2. And I've got this x minus 6 that goes with this x minus 6. That's all I can do. So this becomes what I'm left with at the top, 3 and x plus 6 and 2 and x plus 3. Any questions for that? What do you mean, how do you check if you're right? Good question. If you want to check if you're right, because you're worried, you pick an x value. So I'm going to test, if I test, you want to test? Let's test. Test x is 1. As long as it's not in your restriction, it can be tested. Now, if I plug in x equals 1 in here and x equals 1 in here, if I've done this correctly, I should get the same value. So 3, 1 plus 6 over 2, 1 plus 3. And you can choose any x for this if you want. 1 and 0 are usually the easiest. So I have 3 times 7 and 2 times 4. That gives me 21 over 8. If I take that one, 3x plus 6. 1 squared minus 4 times 1 minus 12 plus 1 squared minus 36 over 2 times 1 plus 6. So here you get 3 plus 6 over 1 minus 4 minus 12. Here you get 1 minus 36 and 2 plus 6. So you get 9 over 1 minus 4 is negative 3 minus 12 is negative 15. Here we get 35 negative over 8. So we get 9 times negative 35 gives me negative 315. Negative 15 times 8 gives me negative 120. And if you reduce this on your calculator, you get 21 over 8, which is the same as this, which means you've done this properly. I would only do this on the final if you have time at the end. Okay, so you can do this just to check to make sure you've done it correctly, but you don't want to spend so much time doing this either. Is this good? So yes, one of the questions is when we factor, we use any way we can, right? And the answer is yes. So your first step is always seeing if you can GCF factor something. And after that, you use whatever you can. Grouping, product sum, perfect squares, difference of squares. Basically, we learned all those tools to put them in a toolbox, and you just have to use whatever you can. Let's do one more before we move on to division. Okay, I'll just answer that question and then we'll move on. Perfect square is either this or this. That gives you 3 terms. So it's the something times itself. So the question, just to make sure everyone's on the same page, is what is the difference between perfect squares and difference of squares? So what ends up happening here is we get 3 terms. So we're multiplying something by itself to give us 3 terms. So usually we're working this backwards. A difference of squares is when I take something and I multiply by the conjugate. And because I'm multiplying by the conjugate, I don't get a middle term, and the last term is negative. So you have GCF factoring, grouping, product sum, and those 3 different relationships to help you factor. Okay. Let's do one more. So we've got 1, 2. That's a 2 again. Good grief. 3 and 4. Uno, 2x plus 3 is factored. 2, x minus 1 is factored. 3. I have a trinomial. There's no GCF, so I'm product summing it. Product of 3 sum is 2. That gives me -1 and 3. So then I get x squared plus 3x minus x minus 3. Here I group, pull out the x. Here I'll pull out a -1, leaving me with x plus 3 as well. And this gets regrouped. So x plus 3, x minus 1. Cuatro. 2x squared minus x minus 6. Product is -12. So I have a sum of -1. So since the sum is negative, the bigger numbers are negative. I have 3 and I have 4. 2x squared minus 4x plus 3x minus 6. Grouping. Here I pull out a 2x, so I'm left with x minus 2. And here I could pull out a 3, so I'm left with x minus 2. Rework this. And this is what we've got. If you see this sentence, if you see this sentence, you do not have to do the restrictions. They're saying, look, we know that the denominator is not 0, so you don't have to worry about that. We're acknowledging it. Just solve the problem. So if you see that, I don't do the restriction step. The next step I do is just putting my stuff together. So essentially, I'm turning this into its factors. So I am saying that this is 2x plus 3 over x minus 1. This turned into x plus 3 over x minus 1. Whoops, what am I doing? Good grief. I have Friday brain, you guys. X minus 1. And here I've got x minus 2 and 2x plus 3. Now all you're doing is canceling factors. So I've got a 2x plus 3 here and a 2x plus 3 here. I've got an x minus 1 and an x minus 1. So what I'm left with is x plus 3 over x minus 2. Can I do number 4? I can, but it has to be very quickly because we do need to move on. Okay. This one's actually not too bad. 1, 2, 3, 4. 1. Can I product sum this? Well, the product is 4. Sum is 2 negative. That's never going to happen. So I leave it. 2. A squared minus 4 is a difference of squares. A minus 2, A plus 2. 3. This is a perfect square. So I actually have A minus 2 all squared, which I can write as A minus 2 times A minus 2 if I want to put it in nicely into the equation. Here I have a product of 4 and a sum of 2. I run into the same issue where I can't do anything. So all I'm going to do is I'm going to take a negative out of it. So it's going to be negative 1 times A squared minus 2A plus 4. What this gives me is A plus 2, A squared minus 2A plus 4 over A plus 2, A minus 2. Here I have A minus 2, A minus 2. And here I have negative 1, A squared minus 2A plus 4. Canceling factors, plus 2, minus 2, minus 2. And this whole thing goes away with this whole thing because they're identical. I'm left with A minus 2 at the top and negative 1 here at the bottom, which you can just bring to the top if you want to. I know that was very, very quick, but we do have to move on to division. All right. Give you a minute to copy out the blue. I took out a negative 1, so that way that trinomial and the other trinomial would match. And I could cancel them out. Okay, so just like with division of fractions, the only difference between division and multiplication is that I flip the second fraction. So when you had 2 over 3 divided by 6 over 12, you would just say, well, this is 2 over 3 times 12 over 6. So we're going to use the same idea. But like I said, we always have to start with factoring and then restrictions. Now notice that here, in the original expression, this is a denominator and this is a denominator. But in the new flipped expression, this is a denominator and this is a denominator. So if you're stating restrictions, you need to include anything that ends up being a denominator. Meaning that you need to state the restrictions for this denominator, this numerator, because it will become a denominator, and this denominator. So like I said, this is the only case scenario in which we find the restriction of a numerator. And it's only because after the flip, it becomes a denominator, and we still can't divide by 0. After that, we just do our flip, and it's a multiplication. So just like what we just practiced. All right, so let's try this first one. 1, 2, 3, 4, 1, x squared minus x minus 2. I have a product of -2 and a sum of -1, meaning I have 1 and -2. So I get x squared minus 2x plus x minus 2. Here I pull out an x, and I'm left with x minus 2. Here I take out the 1, x minus 2, and regroup to give me x minus 2, x plus 1. 2, x squared minus x minus 6. I have a product of -6, so 1, 6, 2, 3, and a sum of -1, meaning that these ones are negative, and I have 2, -3. So x squared minus 3x plus 2x minus 6. Here I can take out an x. Here I can take out a 2. And I'm left with x minus 3x plus 2. 3 is factored and 4 is factored. Now when I'm stating restrictions, I need to state the restrictions for 2, 3, and 4. Meaning I have this factor, I have this factor, I have this factor, and this factor. So for 1, x minus 3 equals 0. 1 never becomes a denominator. It stays as a numerator through the whole thing, so it doesn't matter if that becomes 0. So x is 3. Here, x plus 2 is 0. So x is -2. From this one, x plus 1 is 0. So x is -1. And here, x plus 2 is 0. So x is -2. Which means that my restrictions are x cannot be 3, -2, -1, and we already have the -2, so we don't have to write it again. So we just rewrite this with our factors. So we have x minus 2, x plus 1. And here we have x minus 3, x plus 2. Now what I'm going to do is I'm going to change this to a multiplication. And these flip. And now I'm canceling any factors that double up in the top and in the bottom. You have to do the flip before you do the cancel. Choop, choop. Gone, gone. And this gives me x minus 2 over x minus 3. In this case, you always find the restrictions of anything that's a denominator. So for divisions, it's the bottom of the first and both of the second. That's it. It's not a decision. It's just, it's the bottom of the first and both of the second. That's it. And those are all your restrictions. Okay. 2. 1, 2, 3, 4. 1, 3x squared plus 8x minus 3. My product is negative 9. And my sum is 8, meaning that these two are negative. So I'm choosing this. So 3x squared plus 9x minus x minus 3. Here I regroup with a 3x being taken out, leaving me with x plus 3, and a negative 1 here being taken out, leaving me with x plus 3. And I rearrange. X plus 3, 3x minus 1. 2, x squared plus x minus 6 gives me a product of negative 6, finding the factors of 6, and a sum of 1, meaning these two are negative, so I've got this one. X squared plus 3x minus 2x minus 6. Regrouping here, I can pull out an x, and here I can pull out a negative 2. And I rearrange. X plus 3, x minus 2. 3 is factored, 4 is factored. Restrictions come from 2, 3, and 4. So 1, 2, 3, and 4 here. From 1, x plus 3 is 0, so x is negative 3. From here, x minus 2 is 0, so x equals 2. From here, 2x minus 1 equals 0. Bring the 1 over to give me 2x minus is equal to 1. Divide by 2, and we get x is 1/2. From here, x minus 2 is 0, so x is 2. So my restrictions are x cannot be negative 3, 2, or 1/2. And the 2 doubles up, which is fine. So then I'm basically taking this and breaking it into the factors. So I'm saying this is x plus 3 times 3x minus 1 over x plus 3x minus 2. If you want to do the flip right away, you can. So this turns into a multiplication. The x minus 2 comes to the top, and the 2x plus 1 goes to the bottom. Now I play my canceling game. I got an x plus 3 on a top and a bottom, an x minus 2 on a top and a bottom. This gives me 3x minus 1 over 2x plus 1. Yeah, you're right. Sorry, I made a mistake here. Negative Fabulous. View. Okay, we'll do this one, but we'll do the whole, this part of it, so that we don't have to worry about restrictions. So, move this dumb circle out of the way. All right. One, two, three, four. If you notice right away, yeah, the problems are really long. If you notice right away, the only one that needs to be factored is number 1. GCF, I can pull out a 4. Now I have a product of 6, a sum of 5, meaning I have 2 and 3. Regrouping here gives me, pull out an x and I get an x plus 3, pull out a 2 and I get an x plus 3. Regrouping gives me x plus 3, x plus 2. Now, because they said, given that the denominator is not equal to 0, I don't have to do restrictions. So I just straight up say, well, you're 4, x plus 3, x plus 2, divided by x plus 2. This becomes a multiplication, and this flips, x squared over x plus 5. The only thing I can cancel is that. So I just put my denominator together and my numerator together. And I'm done. So this one was significantly shorter than the others. How many factoring things you have to do will directly impact how long it takes. All right. We're ready. 2 more little things to talk about today. Plenty of time. Adding and subtracting. Last thing we are doing with rational expressions, and then we move on. All right. What we are going to be doing, again, it's the same thing as fractions. We have the 2 added steps of factoring and stating the restrictions. Then we find the lowest common denominator, which we're doing a little differently. And then you're going to multiply by the missing terms to account for the lowest common denominator. And then just like with fractions, you add the numerators, recopy the denominator, and that's it. Do you need 30 more seconds, or can I go to the problems? No takers, cool. So here we go. This is our first adding, subtracting example. So we have to factor. This is factored. This is factored. This is factored. So all we have to do is factor this, which I'll do right in the expression because this is just a difference of squares, which means it's x plus 1, x minus 1. And then we have this recopied. Restrictions would come from here, here, and here. So I'll do it on the side. X plus 1 equals 0. So x is -1. From 2, x minus 1 equals 0. So x is 1. From 3, x minus 1 equals 0. X is 1. We just had that. So my restrictions, I need to move this over a little bit. My restrictions are x cannot be -1 or 1. So the way we find the common denominator is a little bit different because we don't have numbers. So how we approach this slightly different. So what we do is we compare denominators to see what is common between the two of them and what is missing between the two of them. So if I compare, I see that x minus 1 is present in both. So that's fine. What I see here is that this one has an x minus 1, that this one doesn't, but it needs it. So I'm going to add it. But in order to add it, I have to add it to the top and to the bottom. Now if we look, this denominator is the same as this denominator. So all we do here is we're going to put it together. So I have x minus y over x plus 1, x minus 1, plus this y minus 1 times x plus 1 over the same denominator. Since they are the same denominator, all I do is just like with fractions, I just add these numerators together. So I just say x minus y plus y minus 1 over x plus 1 all over my common denominator. X plus 1, x minus 1. Now you want to reduce this as much as possible. So what I am going to do is, it's annoying, but you have to do it, is that I'm going to FOIL this in just to expand it to see if there's anything that'll cancel out. So x times y is xy. Y times 1 is y. -1 times x gives me -x, and -1 times 1 gives me -1. Now I'm going to simplify what's in the numerator. So I have an x and a -x. They go away. I also have a y and a -y, so they'll go away. So my simplified version is just what I'm left on the top with on the top and what I have on the bottom. Questions? All right, let's see how another one of these work. So it's cause almost for celebration when all four of our terms, sorry, are factored. You're like, yeah, I don't even have to do that step. That's amazing. But I do have to do my restrictions. Actually gonna erase this. So from here, I have restriction 1. So x plus 3 is 0. So x is -3. And from here, I have x from 2. I have x minus 3 equals 0. So x is 3. So x cannot be -3 or +3. Go away. All right, so from here, why does it keep doing that? Give me 1 second. Did this in the last class too. Computer is not happy. Whoops. Sorry about that. Okay, thank you, computer, for being a big pain. Where am I at? Oh my goodness. Sorry, guys. Fantastic. So we've done the restrictions on the other page. I'm not redoing them because they're the worst part. So now what I'm doing is I'm comparing denominators. So I say I have an x plus 3 here. Do I see that in this denominator? Nope. So I need an x plus 3. And then this one's taken care of. But here I see an x minus 3. Do I have that here? Nope. So I need an x minus 3 over here. And now if we look, our denominators are the same. They both have an x minus 3, x plus 3. What this gives me is I take the top here, and since this is a plus, I add x plus 3 all over x plus 3, x minus 3. You are not canceling anything out. No canceling. But I am going to expand a little bit to see if I can get rid of something. So this is a perfect square. So I'm going to use my perfect square knowledge to do that one here. This is also a perfect square. So cool. Second perfect square knowledge to expand that. And I'm not expanding the bottom. What do I notice? I have a negative 6x and a positive 6x that go away. This x squared and the x squared becomes 2x squared. 9 and 9 gives me 18. And I can just factor a 2 out of here. And I'm done. A ginormous pain, I know. If you're lucky, you won't get this as a part A or part B question. All right, let's do one more. You should try to put it together as much as possible. So the question is, why did I do the last part, the factoring at the end? Because this looks a lot better than this. So it's a lot simpler, and I've just gotten rid of anything that I can get rid of. Okay. Cool. All right, let's do number 3. But what I'm going to do is, because we're running out of time, I'm just going to factor this quickly. And then you can practice the factoring later if you want. Now this is going to be one of those given the denominator is not equal to 0 problems. So we're going to skip over the restrictions. So here's what we are going to do. We start with the first one. I say I have an x plus 1 here and an x plus 1 here. So that's fine. But I have another x plus 1, which means this guy needs a second x plus 1. Okay, so it's just before I continue this, the question is, do I think that they would try to trick you in multiple choice? Multiple choice for the most part are usually the more straightforward questions. So hopefully not. In the there are questions where it's you have to do the multiplication or the division and then what's the answer, like match your answer. But they're going to do it as simple as possible. So you have to do it as simple as possible. In multiplication division, it's pretty straightforward. In addition subtraction, it gets a little dicey. So you just have to reduce as much as possible. So if multiple choice you don't see your answer there, there's probably something that you can do more. But the hope is that you would get more of a multiplication or division and not necessarily an addition or subtraction. But you never know. Finally, here, I'll do the blue. I have an x plus 3 that I don't have here, so I need to put it. So now I get x plus 3, x plus 1 minus this multiplication over my big, huge denominator. Now this one's a bit different of an example because we have something, x plus 3, x plus 1, minus that exact something. That gives me 0. 0 over this mega denominator. But 0 is 0, right? So that is us finished with rational expressions. We're going to do one little thing right now before we end class. It's not very long, and we've actually been doing it without doing it, without actually formalizing it, just like with the difference of squares, that's what we were doing. So we'll take a look at what this is. 75, please. So now we've been doing a lot with these second degree equations, all the different factorings. But if you actually have to solve the second degree equation, what do you do? So these are the steps. So I'll let you write it down, then we'll talk about it. Okay, so just while you're finishing up, I'll start explaining. The zero principle states, so we're going to be using this idea. So it's the zero principle, it's like a rule in math, states that if you have things that multiply together and the product is zero, one of those things has to be zero. Because there are no two numbers that I can pull out of the world that when multiplied together will give you zero, unless one of them is zero. So if A times B is zero, then either A has to be zero or B has to be zero. So we're going to be using this to help us solve quadratic equations, second degree equations. So what are our steps? You're going to set one side of the equation equal to 0. You're going to factor, and then you're going to set each factor equal to 0 separately. So similar to what we were doing with restrictions when we took each of the factors and set them equal to 0, it's the same thing. Except in this case, instead of those being restrictions, these are our solutions. Let's take a look. So this is now an equation because I've got the equals 0 side of things. So this is now an equation. One side is 0, so I can skip that step. So I'm going to factor. After this, we should be so used to factoring. Hopefully. So I have a product of negative 15, a sum of 2. Meaning that the smaller numbers are negative, so I have negative 3 and 5. So I have x squared minus 3x plus 5x minus 15 equals 0. Here I pull out an x. Here I can pull out a 5. I regroup. So these get pulled, and what am I left with? X plus 5. Seriously, hopefully after a few more practices of doing this on your own, it becomes almost second nature. Now, I take each of these factors and I set them equal to 0 separately. So I have the x minus 3, I make it equal to 0, which gives me x is 3. I have the x plus 5 equal to 0, so x is negative. Why? The pen doesn't always listen to my brain. So x is negative 5. So my solutions, oh my goodness. Are x is 3 or negative 5. Let's take a look at another one. So the first step is done for us. One side is equal to 0. So that's done. So now I'm going to factor this. So I have a binomial. It has a GCF of x, and I'm left with 2x plus 5. Seriously, it's almost a joke now. I now separate each of these factors. So I have this factor, so x is 0, and I have this factor, 2x plus 5 is 0. So I have to solve this one. So 2x is negative 5, and I divide by 2 to give me x is negative 5 over 2. So my solution is x is 0 and negative 5 over 2. Those are my two possible answers. Questions? Cool. Number 3. So unfortunately with number 3, we don't actually have one side equal to 0, so we have to manipulate this equation. So the first thing I have to do is I have to make it look like something that's factorable. So I can't have these brackets and nonsense. So this is 4x squared minus 12x, which is equal to -9. And then I bring the 9 over because I need one side to equal to 0. Oh my God. Plus 9. Trinomial, no GCF, product sum. Product is 36, so I have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. My sum is -12. So all of these are negative. So I have this. So I factor here. I can pull out a 2x, which leaves me with 2x minus 3. I can pull out a -3 here, which leaves me with 2x minus 3. And if I regroup, I actually see that, I had a perfect square if I wanted to do that, but I would have had to recognize that. Now, if you have a perfect square, you can write this as 2x minus 3 squared equals 0. You only have to do one of the factors because they're identical. Don't do the same thing twice. So 2x minus 3 equals 0. Bring the 3 over. 2x equals 3. So x is 3 over 2. And in this case, you only have one solution. How are you feeling? Do we need to do one more? Let's do one more very quickly. No feedback means one more. This one's quick, so let's do it. Here, I can pull out a 2, so I'm factoring. One side is 0, done. I'm factoring. I can pull out a 2, so I get x squared minus 25 equals 0. Here I have a difference of squares, so I have 2x minus 5, x plus 5 equals 0. I take each of my factors and set them equal to 0. So in this case, x minus 5 is 0, so x is 5. X plus 5 equals 0, so x is -5. So my solution, our x is -5 and +5. Questions? So I'm going to leave it off here. Just a couple of things before you go. I'm going to be hopefully looking at assignment 3 this afternoon. So heads up for that feedback. Make sure you complete assignment 4. So we did a lot of it in class together today, but still try to do it on your own. That way I can give you feedback for what you're doing wrong if you're having difficulty. And assignment 5 will be posted in about 5 minutes. So you'll see that notification pop up. So once again, you've got the Google form and you've got the doc to look over. Next week, I'll be talking more about the situational problem and what topics you need to put on your memory aid, and we'll talk a bit more about the memory aid itself. If there are any questions between now and then, feel free to email me. Just before you go, I got 2 little questions that popped up in the chat. So about this problem, okay, so question number 1, what happens with the 2? 2 is not a variable, so 2 does not impact my answer. Okay, if I include the 2, one of these would have just been 2x minus 5 equals 0, and the first thing I would have done would be divide by 2. And when I divide anything, 0 by anything, I still get 0. So the number coefficients don't impact my solutions. Second question is, can there be 1 or 2 or 3 solutions? There can either be, when you're dealing with 2's, There can be 0, 1, or 2. If you're dealing with something like this, there could be 3, 2, 1, or no solution. Okay, so it has to do with the exponent. So general reminders, please do the assignment. The handout will be posted also in about 2 or 3 minutes. It's a lot of rational expressions. There are a ton of pages. Obviously, I don't expect you to complete it all, but the solutions will be posted tonight. So try to do as many as you can because this is very, very good practice. And there's a ton of factoring in that, which also helps you. If you have any questions, feel free to email me or to post on Google Classroom. Other than that, take advantage of the horrible weather to do some math work. And have a great weekend.